for math review, you need to work together. Look back on your previous days to help you. This is now day 5 or 6. We're getting close to the end of the cycle. All right, guys, you should have the problems written down by now, so I should start hearing math talk, please. Start working together, compare your answers.
Is that number 2 yet, or?
I got x squared minus y squared.
You might have to multiply that though, so you don't have a radical denominator. Instead of doing the fifth power, I'm multiply that by
So you have the last one.
5x minus 3.
5x.
Oh wait, no, 2x.
What? How do you distribute that?
Hang on, I'm not done yet. Almost done. I get 2, 3.
About 2.5 minutes.
How do you do on this one? You want to catch up on this?
How did you get 700 the first time?
Because it's 3 times 3 is 9 times 3 times 3, times 3, and times 3. And that
Oh,
was
I
5
did it
times.
wrong. Yeah, 6 times. Yeah.
Dude, but how can you keep count? That's like 1, dude. It's 1 right there.
It's 2.
2. 3.
No, because the first time it's 2.
You don't count the first one?
3 times 3 is 9. That's 2.
So then I got 1 over x plus y squared times 1 over x minus y squared, and then I distribute it or whatever. And the y's cancel out. I think.
Because one's positive.
Yeah.
one's negative.
And then I get the square root. And then, but this cancels out.
And then
So
it's
you-
just 1 over.
Not. That's what I'm thinking.
I'll let you finish. What'd you say?
I just got the square root of x squared minus y squared.
Square root of x squared minus y. What'd you do though?
Just multiply both of them by the reciprocals.
By the reciprocals?
Yeah. So 1 over square root of x plus y.
They're both to the negative 1/2, to the power of negative 1/2. So they're both gonna be under 1.
Yeah. Then you just multiply from there. What did you get for your base?
For number 2, this is what I have. Square root of x squared minus y squared over x squared minus y.
What one is going to be positive? Like x squared plus y squared. Wait. Oh no, you're correct. Yeah, I got it.
Okay, pencils down. Grab a color. Pencils down, grab a color.
Maybe that color. What did you get? What?
All right, Joseph's going to be our scrub person today. All right, one voice, please. We should be listening, be respectful, and processing your problem. Okay, Joseph, whenever you're ready.
Okay, so give yourself a star if you wrote math review number 35. The day, work, and reflection. Rational expressions. And if you wrote the problem down correctly. I recognize that we could separate this into the power of 5 and the square root or the power of 1/2 because 1 over 2 is equal to the square root. And I got the square root of 9 to the power of 5. And the square root of 9 is 3. And 3 to the power of 5 is 243. So give yourself a star if you separated the two. Had 3 to the power of 5, and give yourself a star if you got 243 a chance.
Go ahead and freeze. Reflect, please. If you made a mistake, circle and fix. down now so that you have it to look at tomorrow. As soon as you're done writing your reflection, please share with your team. You may either just swap books and share, or read to each other. Please hold your team members accountable for writing great reflections. If they wrote a great reflection, give them a star. Please share.
I did a good job. Then we have to write the radical.
These are key concepts number one.
Can you use the key concept number 1?
For any natural.
Yes. For any natural. On the next one, being a radical fraction. Use the fraction bottom of to create the radical. And the top of to create the exponent. So after you've done doing the radical, use the exponent. Okay? What did you write? I got the video.
You did it right.
I got this.
I separated the problems. I got three
All right.
systolic.
So what is the key thing we need to remember for the first problem? Christian, I heard you starting to say it. What's our key concept?
For any natural number, m and n, and any non-negative number, you move it. Wait, I'm not sure.
In your words, what's the main thing?
Oh, to move if it's a fraction, the bottom number of the fraction exponent becomes the radical, and the top number becomes the exponent. So after you're done simplifying it under the radical, you use the exponent to multiply it through.
Perfect. Great. All right. One voice, please, for number 2.
Give yourself a star if you wrote the problem down correctly. And I recognize that the square root, the power of 1/2 is equal to a square root, and the negative makes the square root go under 1. Because there can't be a negative radical or a square root. So I put them both over 1. Give yourself a star if you've done that. And I multiply them to get the square root of x squared minus y squared. Give yourself a star like that. And I remembered that there can be a square root in the denominator, so we have to rationalize the fraction. Give yourself a star if you done that. I got the square root of x squared minus y squared over x squared minus y squared. Give yourself a star if you done that.
Go ahead and freeze it. All right, reflect for number 2. If you made a mistake, circle fix. You didn't do this problem. Write it down now so that you have it for Monday. reflection. Please share with your teams.
Negative power makes the equation like a fraction, and that the 1/2 exponent makes into a radical. So then I multiplied by the
So not be a square root in the denominator, and to get rid of it, I need a fraction.
One over square root of x, and no radicals can be in that denominator.
Well, I remember that in order to get rid of a negative from the exponent, you have to do the reciprocal, and then I also remember that if a set of variables is being powered by
What's our
1/2,
key concept for
you
number
change it to a
2?
square root,
Something you want to
and
explain
then
in your
there
own
cannot be
words?
a
What are the
negative.
main things we need to remember? What do you need to remember? Okay, no radicals in the denominator, which means we need to do what? Rationalize? What else came out of this problem? Key concepts we need to remember. It says rewrite without rational exponents. How do you do that? Take the fractional exponent and I heard a voice. What do you do with it?
You can any radicals.
Okay, we said that. We said radicals in our but the instructions say rewrite without rational exponents. So what's the key concept of rewriting without rational exponents? Well, how do you get rid of the rational exponent?
You flip the radical.
Okay, good. So turn the fraction into a square root in this case. All right, good. All right, number 3. One voice, please.
For number 3, give yourself a star if you wrote the problem correctly. I recognize that I can factor out 5x from the numerator and got 5x to 2x minus 3 over 5x, and the 5x cancel out, leaving me with 2x minus 3. Give yourself that happy face and correct that.
Okay, don't freeze it.
My cricket.
Made a mistake. Circle fix.
My goal will be
Guys, go ahead and reflect. Since you're done writing reflection, please share.
Alright, so I got my answer by realizing that if I can factor out a 5x, a common multiple, within the 2x minus 3 in the numerator. And once done, I can simplify further by getting rid of the numerator and the denominator to finally get my full answer of 2x minus 3.
Sign. We did it. We got all the right.
I recognize the 5 used to for 5 minutes. And cancel out.
We got them all right for once.
Don't clean up yet, please. Don't forget we got to talk about key concept first. All right, what's our key concept for number 3? When do we know we're fully simplified?
When you cancel out the common factor.
Okay, so when the common factor's been canceled out. All right, awesome guys. Thank you, Joseph. Go ahead and clean up.
I'm gonna share my
I don't know.
The graph paper in the center is actually for your group, not necessarily one per individual, okay? You use the graph paper as you need to. I just put 3 on the table so that you have it. I was thinking actually 3 groups versus 3 people, okay, as I rotate you 3 groups, so you may use it as you need. Pen because, well, actually, you're not taking them home, huh? So if you want to use pencil, if you're a pencil person, that's kind of silly. The reason I always made you use pen for alternative method was so you can't change your answers, but you're doing it all today. Yeah, everything's happening right within this period. So if you're a pencil person, I don't care pen or pencil, but if you usually like to use pencil for math, it doesn't matter today. Okay? Put up our hint board. Remember, I have an expectation to get at least 3 hints before the end. I would appreciate more if you can. And I really think that today, if you come up with something, don't keep it to yourself, okay? Share your ideas. What's wrong, guys? Stuff. 1, 2, 3, I count okay? Okay? So it's a star. Hopefully it won't bug you. Yeah, just want to make sure that you don't end up with these. All right, as soon as you get your problem-solving writing guide, please go ahead and number off 1, 2, 3. Okay, who's 1, who's 2, who's 3 in your group? Okay, write your number down.
Are you 2? Okay, that's my
Wait, where's the... Oh, it's right here.
All right, we ready? 1, 2, 3. Okay, so go over the problem. So being that it's the holiday season, the elves are extra busy making toys, Santa's workshop. Each and every day they focus on different toys. So sometimes they're making stuffed animals or dolls or planes or trains, and the sizes of the toys change, right? Sometimes the dolls are small and stuffed animals might be big. Okay, so based on the different sizes, they need your help because Santa has asked the elves to package the toys into open-topped boxes. We say open top would be like this. It just doesn't have a top on it. Okay, open box. So to store stuff in. Okay, so Santa wants the elves to put all the toys in the box, store them until they're ready to go into his sleigh. So you need to find proper dimensions to help make these open top boxes so that they can hold a maximum volume of toys. So be able to hold the most amount of toys possible. Okay? Given a rectangular piece of material. So in order for you to help develop a general formula or a general way for the elves to do this for any size piece of paper, I've provided you with an 8.5 by 11. Okay? I want you to actually use inches measurements for this, 8.5 by 11, not counting unit squares. The only reason I gave you graph paper over white paper is to help you cut straight lines. Okay, it's a way to make an open top box is to cut out a square. So you're actually going to probably need to use a ruler because you can see the graph paper, the bottom doesn't have like a, it cuts off, like it doesn't have a whole square. That's why I'm saying don't use it as units. Maybe you measure off like an inch and an inch. And then you're just going to cut out, okay, and if I cut out a square, and like I said, the only reason I gave you craft paper is so you had lines to guide you so that you could cut out a straight square. And if I cut out a square, this isn't going to be perfect because I didn't measure, you know, all 4 corners, I can very easily make my open top box because now I can fold up, right? I can fold up a side for my box. And if I cut all 4 corners, I can fold up, right, all 4 sides, and that makes my box. Okay? So again, don't use the squares on the graph paper as unit squares. You actually measure with rulers. I'll come around with rulers in a minute, make sure you have them. Okay, so as you're cutting and folding. Okay, so I'm giving you this hands-on to help you for your visual part and hands-on to see what's happening. So the first question is I actually want you to find the maximum volume obtained from an 8.5 by 11 piece of paper. So using this size rectangle, what is the maximum volume that you can get? And what are the dimensions then of that box? And remember when I say dimensions, because in paper, I have length, I have width, and now that I've made a box out of it, it has height. Okay, so when I'm asking for the dimensions, what's the length, what's the width, what's the height? Okay, for this piece of paper. Then, secondly, you need to develop a general formula that the elves can use so that they could create a box for any size rectangular piece of paper. What if they have a, you know, obviously some of the toys are big. This isn't going to make a very big box. They need big boxes. So if they have a big piece of rectangular paper, how are they going to know how to cut it to make the box? So you need to come up with a formula for them, okay, and describe to them how to do it. Okay? So 2 parts. Find maximum volume of your 8.5 by 11 and what are the dimensions? Second part, for any size rectangle, how can you find maximum volume and find dimensions? Okay, come up with a general formula. Questions or clarifications on the problem? Okay, first 5 minutes is quiet time. So for you to start working, okay, so you to start thinking about what information do I need to know, start putting your thoughts on paper, you know, whatever you think you need, okay, but it's time for you to kind of think for yourself. So first 5 minutes is quiet time. I will come around with rulers right now. So now at this point you've had 5 minutes of quiet time. What I want you to do on your problem-solving writing guide. Okay, so find your writing guide. It's the other page, not your data sheet, it's the other one. Okay. At the top it says individual work. Okay. I want you to quickly, within the next couple minutes, go ahead and reflect on what you just did for that during that quiet time. Okay, what is your thinking at this point? What is your understanding? Okay, remember it's a recollection. Don't just regurgitate what you did on your data sheet. Like don't say, well, I multiplied 2 times 2, but why? Okay, the reflecting part of it. So what's your thinking right now? What is it of the problem you understand? Where are you at? Okay, so let's take about 2 minutes to reflect. wrap up those reflections. So at this point, you're going to start working with the group that you're currently in. Okay, reminder, make sure, I'm sure I know I told you, but make sure you numbered off 1, 2, 3, so you all have a number. Okay. As you're working, think about everybody in the class. Get boards up. So if you've got something you think that would be valuable to everybody, please share. So we've got, since we have a bigger period today, okay, we got a little bit more time to work, so I'm gonna try to give you a little bit more time in your groups, but I am gonna try to watch the time to make sure you get to talk to as many people as possible before you do your final write-ups, okay? All right, as you start working with the groups, take a minute, go around your group, make sure everybody gets a chance to share. So give everybody a chance to voice, just go around maybe 1, 2, 3, okay? Whoever's number 1, share, who's number 2, share, whoever's number 3, share, and then work collaboratively. Any questions? All right, go ahead and start working.
So, alright, what I have so far is the graph or the equation is gonna be a parabola. It's gonna be a, what are they called? A parabola, pretty much, right? And we're gonna have to graph. So the amount that we cut, it's gonna be like negative 2x or negative 3x squared. But I don't know what it is, so that's what I gotta do, like guess and check, or I'm gonna graph it. But then I don't know what to do with 11 and 8.5. I think that's just gonna be like x and y. I mean
Like wouldn't like what you cut off here, you have to subtract.
that's why. So you're gonna subtract it. So you're gonna get like negative 2x squared plus like.
And I think
I don't know. That's what I'm trying to.
you can't really add.
Alright. Because alright, so when we cut it out, because alright, so parabolas have maximums, right?
Yeah.
And in order to get a maximum, you have to have a negative ax squared. So that means a has to be a negative number, but and a is gonna be the amount of like squares or like amount of inches that we cut into the paper.
So we know what.
Well, it's
We have a negative
it's gonna be a negative a squared, and it's parabola, so it's gonna be. But then.
initials, right? Because you have to cut a piece of it to get the rest of it.
I don't know what on
Because that's half of it. I mean, no, half of that. Sorry. So it'll be like.
the vertex to the middle. So then that means this equation is never like maximum.
Wait, what's 4.25? 4.25 is half of the 8.5. I have half of the 8.5, so that would.
And you're trying to cut them.
No, that's not what we could have done. We won't get anything. So it'll probably be like right here on each one.
So we're subtracting what the A is. Minus 3 every inch. I feel like that.
Should we do that?
That's what the actual height, right? And I want 2 different heights. Okay.
So you're just gonna keep drawing rectangles? Yeah, instead of pyramid.
Just how far are you going? Won't the volume just get small? Is your volume? Yeah. So wouldn't the biggest be 1?
No, because that was. No, because the volume of it, if you cut out a 1 square by 1, it'd be 58.5.
So the biggest is 2.
But I'm gonna try like 2.5.
Hey, that's actually it.
I divided by that. I divided by 1.5.
Because X would be
Label. I'm gonna label it. Label it.
But,
What about the rest of the labeling? You need more labeling than that.
like this.
Yeah, the whole thing.
And maybe if you factor it out.
Oh, no, it's on your diagram. Where's the-
When you're
Alright.
so you're basically just subtracting this is to 2, right? So what if we want
All right, pause your conversation for just a second. We have a hint. Okay, we have a diagram hint. Would you please share the thinking in your hint?
Alright, so the box, like or the paper that the cardboard is 8 by 5. I mean 8.5 by 11. And when you cut it in, that's gonna be X.
And what's your thinking why you're calling it X?
Because that's height. So like when you cut into it, that's gonna affect the height. Because if you have volume is length times width times height, and if you don't have height, then the volume is 0. So then that means you have to have a value for height, which would be X. So that's gonna be.
Okay,
volume
stop there.
equal.
You're gonna give them too much. Okay. All right, take it or leave it. Okay, take the hint or leave it if you agree, or if you have a different method that you're using, keep going with the method you're using, but there's a hint. And the hint is to call the height X.
I think that's a legitimate statement.
I did too. What'd you give it to? I got 91.
First I had so so height of the
As you start,
No, but you know what? It's because it's like getting negative numbers. There's a certain
You're not supposed to have, you can't have negative space.
it's just
No, that's fine. But you don't get negative.
But then
Or like when you put in 5 as an X, and you get negative 7.5, you have negative volume. I mean, I guess
it just like rotates itself, basically.
you can have negative.
5 is the only one.
5 is the only
Yeah,
one
but
that's
this is
Well, I mean, 4, once it's greater than 4, and then once it's less than
Oh, what if we just actively But we don't have I don't know what kind of restrictions
that is.
I don't think there are restrictions. Like it's a weird one.
Oh, wouldn't the thought be what's multiplied from 8.5 and 11?
because that's what it has no height.
Isn't that general formula?
isn't it?
No. And then, oh, for a circle, because square.
All right, go ahead and pause your conversations for group 1. So you've had quite a bit of working time. I'm starting to see some progress come out, but I want to share the love. I want to shake you up a little bit. So on your problem-solving writing guide, okay, go to your problem-solving writing guide where it says group 1 work. Okay, group 1 work. I want you to reflect on your understanding to this point. So as an individual, what do you understand about the problem right now? Okay, so where's your thinking at now after having time working with your group? So go ahead and reflect. Let's take a few minutes. right, my number threes. Number threes. Get ready to pack and stack. I understand you don't have number three. That's okay. Okay? Number threes. Get ready to pack and stack, please. Okay? So my number three from here. You're going this way. My number three from here. You're going to come to. My number three from here. I want you to go there. My number three from here. You're going to come up to there. My number three here, I would like you to come back here. My number three here, it's going to come here. My number three here. Here. All right, number three is pack and stack. Go. As soon as you get to your new groups, okay, as soon as you get to your new groups, please share, okay? New person, share what your group's thinking was. People that are there, share with the new person, okay, what your group's thinking was. You'll be my group of two this time for this round, okay? Okay, so please continue your conversations and keep working on the problem. If you need more graph paper, feel free to get up and grab what you need, okay, as you're cutting and testing and all that stuff, okay? All right.
What I kind of confused is that the bigger the height, the less space we got on the inside. So less toys are going to be able to fit. So less height would mean more volume. So that is why we wanted to try the 1 inch. And the Nate was 3.5 inch.
That's a lot.
Ooh, we had a hit and I missed it. Christian, is that you?
Yeah.
Okay. So, we get to record? Yeah. So let's pause your thinking. Christian snuck a hint up when my back was turned. Christian, do you mind sharing your hint with the class, please?
Yeah. So whatever the height is equal to, you have to subtract twice that amount to the length and width, because x takes up two spaces of this, so this side and this side, and it also works with the width, this side and this side. So 2x minus whatever 8.5 is. Yeah. You have to subtract all the time.
Okay, there's a hint. Take it or leave it if you think it'll work or not. Continue working.
It's because we wrote it the long way instead of just making it shorter.
Yeah. Yeah, if you just put 2x, so we put minus x times 2. You can just put it. So we're making it complicated.
And then the second
X says
It's basically what we did. Yeah. Wherever you go.
Can you do it? No. Do you know what A and B are, at least in this case? Okay.
That's 2.8, and you subtract 2.8 from the length and the width, and you'll get 5.7, 8.2, and you multiply it by the height, which is 1.4, and you get 65.426, which is greater than when we had our height was 2. So let's see if we can try it with 1.3 instead.
So we found the general formula and we graphed it with the length and the width, and it gives you a graph, and you have to like look at it and kind of just be like, oh, there's a max. You graph the general formula, you look at it, and there's like a thingy. I don't know how to explain it.
So basically graph it so you can look at it.
It validates
Okay,
the
so there's
graph.
your hint. So you're saying graph your general formula if you have one. Okay? The graphic so you can look at the graph. That's your hint. Take it or leave it.
And we plug in our calculator, and we got this. And then to find our maximum volume, we gotta just have to find the vertex of the graph. Cool.
All right, allow me to pause your conversations. Try that again. Okay. So at this point, I'm going to pause you with your group 2. Go to your writing guide. Okay, go to your writing guide where it says group 2 work. Group 2 work. Go ahead and reflect on your understanding to this point. Where is your thinking? And where are you at? What do you still need? Maybe any misconceptions you have at this point, what you might need clarified when you move on to your next group. Okay, so let's take a couple minutes to reflect. Number 1. All right. My number 1 here. Okay. Everyone here. I'd like you to come here. My number 1 here. I would like you to come here. My number 1 here. I would like you to go back to there. My number 1 here. I would like you to come to here. My number 1 here, I would like you to come over here. My number 1 here, I would like you to come over here. My number 1 here, I want you to come here. And then my number 1. Okay, go ahead and move, please. I haven't moved you yet. Thank you. I forgot that I moved. All right, so my number 1s have almost moved. Who's my number 1 here? Okay, go ahead and pack and stack. That's okay. Go ahead and take what you have. You'll get
She said she's trying
Right?
Yeah, I can.
So you got that?
No, but with that, you can switch the answer for general formula.
Where we're putting restrictions?
This one.
What are you putting restrictions?
7 and 9.
Need a plug-in point.
Because
And in the original formula,
it can be
what the possibilities of outcomes. So
how you break it.
We don't know how to.
Yeah, you doesn't forget. And then we're going to the formula, and then you can tip it up to get the general. Which is, it should be 4x squared minus 39x squared plus 93.5x.
And then from there you can graph it, you know, something that.
Yeah, right there. So what you would do to see the max is that but it's
Yeah, it does make sense because when you would go up to 30 inches, it would start going down.
and even if you plug in 2, it would go down because it's less than 1.6.
I mean, originally calculated the
That's number 2, right? I did because I plugged in 2. And oh, when you use the table, when you plug in 2, it would be less than 1.6.
Even right here, it went to a really small different value, and it still decreases after 3.
Yeah, because if you graph it and then you look at the table, you can see right there that it starts going down.
So it's past 3.
Yeah. Wait. Because when I graph it, you can see these. Look at. There's 1 and then 2 is 63 and then at 3 it's 37.5. But if you do decimals, because there's still numbers right there.
Oh, actually, I think I did a mistake right here. I think I made an error, but actually there's some value there that when it goes past it, it decreases.
I had it in like, yeah.
Pause your conversations. On your problem-solving writing guide, you need to reflect your understanding from group number 3. And reflect on your understanding from group number 3 on your problem-solving writing guide. Where's your thinking? Maybe possible questions you might still have.
Yeah.
Misconceptions, but where are you at? So go ahead and reflect.
Oh, no.
Okay, for final write-up, I would like you to put up your little cheat cubbies. This is an individual thing. Not that I don't trust you, but I don't trust you. But I want you to, group time is over. Okay, group time is over, so this is no individual time. So this is to keep you from wanting to, I know you're gonna want to keep doing those conversations, but I want alone time now, okay? On the back of your problem-solving writing guide, it says answer and verification. So please tell me what your answers are, and then you need to provide the mathematical reasoning for your answer. So what supports that? Okay, what was your thinking? Okay, what I really want you focusing on is that second part where you had you develop a general formula. What is your general formula? And it says to describe a strategy to the elves, how they can use that general formula for any size paper. Okay, so I want to hear what are you going to tell the elves? Okay, use your 8.5 by 11 and what you did with that as your support. Okay, so for any size piece of paper, how can we get max volume? Okay. Use the 8.5 that you had as the support to that answer. Please be clear, okay, because I am grading on your reasoning and your thinking. Okay, you have about 10 minutes to write, so kind of be to the point. Okay, just get right to it. Okay, don't try to be fancy. Don't try to use big words. Just tell me what it is. Just straight up. This is what I did. This is how I know what I did is correct. All right, rest of the time's yours. Final write-up, due at the end of the period. You got about 10 minutes.